CO and SDO cables present some challenges. The concern is potential damage in environments with confined spaces, floating equipment, and the possibility of contact with seal edges. A cut cable could create sparks. MC-HCL cable is a consideration, but the solid aluminum cover beneath its PVC jacket lacks the needed flexibility. Therefore, or SDO cable with a flexible armored cover might be the best approach. Think of an aluminum mesh type armor. This provides a protective layer against physical damage while maintaining the necessary flexibility. This cable solution is beneficial for painting operations because flexibility and frequent movement are crucial. When selecting a cable, several factors need consideration to ensure safety and compliance with electrical codes. Firstly, the cable must be rated for the voltage and amperage requirements of the equipment it will power. Consult the equipment's nameplate to determine these ratings. Using a cable with an insufficient rating can lead to overheating, insulation failure, and potentially electrical fires. Secondly, consider the environmental conditions where the cable will be used. Factors like temperature, moisture, and exposure to chemicals can affect the cable's performance and lifespan. For example, if the painting operation involves exposure to solvents, the cable's jacket must be resistant to those chemicals to prevent degradation. Thirdly, the cable's flexibility and bend radius are crucial, especially in confined spaces and around moving equipment. A cable with a small bend radius can be routed more easily without causing stress or damage to the conductors. Check the cable manufacturer's specifications for the minimum bend radius. Fourthly, grounding is essential for electrical safety. The cable should include a dedicated grounding conductor to provide a low impedance path for fault currents. This helps prevent electrical shock hazards and ensures proper operation of protective devices like circuit breakers. Fifthly, a National Electrical Code (NEC) provides guidelines for selecting and installing cables. Familiarize yourself with the relevant NEC articles, such as Article 400 for flexible cords and cables and Article 300 for general wiring methods. Compliance with the NEC ensures that the installation meets minimum safety standards. Sixthly, consider the type of insulation and jacket materials used in the cable. Common insulation materials include PVC, polyethylene, and rubber. Jacket materials include PVC, neoprene, and polyurethane. Each material has different properties in terms of temperature resistance, chemical resistance, and abrasion resistance. Choose the materials that are best suited for the specific application. Seventhly, strain relief is important to prevent stress on the cable terminations. Use appropriate strain relief connectors or clamps to secure the cable at its entry points into equipment or enclosures. This prevents the conductors from being pulled out of their terminals, which can cause electrical faults. Eighthly, consider using cable trays or conduits to support and protect the cable, especially in areas where it is exposed to physical damage. Cable trays provide a convenient way to route and manage multiple cables, while conduits offer a more robust protection against impact and abrasion. Ninthly, regularly inspect the cable for signs of damage, such as cuts, abrasions, or discoloration. Damaged cables should be repaired or replaced immediately to prevent electrical hazards. Tenthly, proper labeling and identification of cables is essential for maintenance and troubleshooting. Use cable markers or tags to identify the purpose and voltage of each cable. Firstly, consider the ampacity of the cable. Ampacity refers to the maximum current in amps that a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. The NEC provides tables, such as Table 310.15b16, that list the ampacities of various conductors based on their size, insulation type, and ambient temperature. Selecting a cable with the appropriate ampacity is crucial to prevent overheating and potential fire hazards. Secondly, understand derating factors. The ampacity of a cable must be derated under certain conditions, such as when multiple current-carrying conductors are bundled together or when the cable is installed in a high ambient temperature environment. Derating factors are specified in the NEC, and they reduce the allowable ampacity of the cable to ensure that it does not overheat. For example, If a cable is installed in an ambient temperature higher than 30 degrees Celsius, its ampacity must be derated according to the NEC tables. Thirdly, consider voltage drop. Voltage drop refers to the reduction in voltage along the length of a cable due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to a maximum of 5% for branch circuits and feeders. To minimize voltage drop, use larger conductors or shorten the cable length. Fourthly, select the appropriate cable type for the application. SO and SDO cables are flexible cords commonly used for portable equipment and appliances. MC-HCL cable is a metal-clad cable with a corrugated aluminum sheath and a PVC jacket. Each cable type has different properties in terms of flexibility, durability, and resistance to environmental factors. Fifthly, ensure that the cable is properly supported and secured. Cables should be supported at regular intervals to prevent sagging and strain. Use cable ties, clamps, or other appropriate support devices to secure the cable to walls, ceilings, or other structures. Sixthly, protect the cable from physical damage. In areas where the cable is exposed to potential damage from impact, abrasion, or chemicals, use conduit or other protective measures to shield the cable. Seventhly, follow the manufacturer's instructions for installation and termination. Each cable type has specific requirements for installation and termination. Consult the manufacturer's instructions to ensure that the cable is properly installed and terminated. Eighthly, use the correct tools and equipment for cable installation and termination. Improper tools and equipment can damage the cable or create unsafe conditions. Use cable cutters, strippers, and crimpers that are specifically designed for the cable type being installed. Ninthly, inspect the cable after installation to ensure that it is free from damage and that all connections are tight and secure. Look for any signs of cuts, abrasions, or other damage to the cable jacket or insulation. Tenthly, ground all non-current carrying metal parts of the electrical system. Grounding provides a path for fault currents to flow back to the source, which helps to trip circuit breakers and prevent electrical shock hazards. Grounding conductors should be properly sized and connected to a grounding electrode system. Firstly, consider the conductor material. Common conductor materials include copper and aluminum. Copper has higher conductivity and is more resistant to corrosion, but it is also more expensive than aluminum. Aluminum is lighter and less expensive than copper, but it has lower conductivity and is more susceptible to corrosion. Secondly, choose the appropriate insulation type. Insulation provides a barrier between the conductor and ground, preventing electrical shock hazards. Common insulation materials include PVC, polyethylene, and rubber. Each material has different properties in terms of temperature resistance, chemical resistance, and abrasion resistance. Thirdly, select the correct cable size. Cable size is determined by the ampacity requirements of the circuit. Use the NEC tables to determine the appropriate cable size based on the load and the installation conditions. Fourthly, consider the number of conductors in the cable. Cables can have one or more conductors depending on the application. Single conductor cables are typically used for grounding or bonding, while multi-conductor cables are used for power and control circuits. Fifthly, ensure that the cable is listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, UL. Listing and labeling indicate that the cable has been tested and meets the safety standards of the testing laboratory. Sixthly, protect the cable from moisture and corrosion. Moisture and corrosion can damage the cable and create unsafe conditions. Use waterproof connectors on enclosures to protect the cable from moisture. Seventhly, avoid overbending the cable. Overbending can damage the conductors or insulation. Follow the manufacturer's recommendations for minimum bend radius. Eighthly, do not exceed the cable's maximum operating temperature. Exceeding the cable's maximum operating temperature can cause the insulation to degrade and lead to electrical failures. Ninthly, avoid pulling the cable too tightly. Pulling the cable too tightly can damage the conductors or insulation. Use cable pulling lubricant to reduce friction and prevent damage. Tenthly, properly terminate the cable. Proper termination is essential for ensuring a reliable electrical connection. Use the correct tools and techniques to terminate the cable. Firstly, understand the difference between SO and SDO cables. SO cables are designed for ordinary duty, while SDO cables are designed for hard service. SDO cables have a thicker jacket and are more resistant to abrasion and chemicals. Secondly, consider using a cable with a braided shield. A braided shield provides additional protection against electromagnetic interference (EMI) and radio frequency interference (RFI). Thirdly, select a cable with a UV-resistant jacket if the cable will be exposed to sunlight. UV radiation can degrade the cable jacket over time. Fourthly, consider using a cable with a cold weather rating if the cable will be used in cold environments. Cold weather cables are designed to remain flexible at low temperatures. Fifthly, ensure that the cable is compatible with the equipment it will be used with. Check the equipment specifications to ensure that the cable meets the voltage, amperage, and grounding requirements. Sixthly, use cable glands to provide a watertight seal at the cable entry points. Cable glands prevent moisture and dust from entering the enclosure. Seventhly, avoid running cables through sharp edges or corners. Sharp edges and corners can damage the cable jacket and insulation. Eighthly, protect the cable from rodents. Rodents can chew on cables and damage the insulation. Use cable trays or conduits to protect the cable from rodents. Ninthly, label the cable with its voltage and amperage rating. Labeling helps to prevent accidental overloading of the cable. Tenthly, regularly inspect the cable for damage. Regular inspection helps to identify and correct potential problems before they become serious. Firstly, consider using a cable with a chemical-resistant jacket if the cable will be exposed to chemicals. Chemical-resistant jackets protect the cable from damage caused by chemicals. Secondly, select a cable with a flame-retardant jacket if the cable will be used in a fire-prone area. Flame-retardant jackets help to prevent the spread of fire. Thirdly, consider using a cable with a low-smoke jacket if the cable will be used in an enclosed space. Low smoke jackets produce less smoke in the event of a fire. Fourthly, ensure that the cable is properly grounded. Proper grounding helps to prevent electrical shock hazards. Fifthly, use cable ties to bundle cables together. Cable ties help to keep cables organized and prevent them from becoming tangled. Sixthly, avoid running cables near heat sources. Heat can damage the cable insulation. Seventhly, protect the cable from physical abuse. Physical abuse can damage the cable jacket and insulation. Eighthly, do not overload the cable. Overloading can cause the cable to overheat and fail. Ninthly, regularly test the cable insulation. Insulation testing helps to identify potential problems before they become serious. Tenthly, replace damaged cables immediately. Damaged cables can be a safety hazard. Firstly, understand the importance of proper cable management. Proper cable management helps to prevent damage to cables and ensures that they are easily accessible for maintenance and troubleshooting. Secondly, use cable trays or conduits to support and protect cables. Cable trays and conduits provide a physical barrier that protects cables from damage. Thirdly, label all cables clearly and accurately. Labeling helps to identify cables quickly and easily. Fourthly, keep cables organized and tidy. Organized cables are less likely to be damaged or become tangled. Fifthly, avoid running cables across walkways or doorways. Cables running across walkways or doorways can be a tripping hazard. Sixthly, protect cables from moisture and chemicals. Moisture and chemicals can damage the cable insulation. Seventhly, avoid overbending cables. Overbending can damage the conductors or insulation. Eighthly, do not overload cables. Overloading can cause cables to overheat and fail. Ninthly, regularly inspect cables for damage. Regular inspection helps to identify and correct potential problems before they become serious. Tenthly, replace damaged cables immediately. Damaged cables can be a safety hazard. For painting operations, the selection of a flexible armored cable requires careful consideration of several factors to ensure safety and efficiency. A flexible metal conduit (FMC) or liquid-type flexible metal conduit (LFMC) could offer the needed protection and flexibility. These conduits can house individual conductors of the appropriate type and gauge for the voltage and current requirements. Firstly, consider the specific environment. Is it wet, dry, or corrosive? This will influence the choice of jacketing material for the conductors inside the flexible conduit as well as the conduit itself. Secondly, assess the range of motion required for the painting equipment. The more movement, the more flexible the conduit needs to be. Thirdly, ensure the conduit and fittings are properly grounded. Grounding is critical for safety, especially when working with electrical equipment. Fourthly, use appropriate connectors designed for flexible metal conduit. These connectors provide a secure and watertight seal, preventing moisture and contaminants from entering the conduit. Fifthly, inspect the flexible conduit regularly for any signs of wear and tear, such as cracks or abrasions. Replace damaged sections immediately to maintain safety and prevent electrical hazards. Sixthly, choose conductors with the correct insulation type for the application. THHN/THW-N-2 conductors are a common choice for use in conduits, offering good resistance to heat and moisture. Seventhly, size the conductors appropriately for the load. Use the NEC ampacity tables to determine the correct conductor size based on the current requirements of the painting equipment. Eighthly, consider using a cable with a low coefficient of friction to make it easier to pull through the conduit. This will reduce the risk of damage to the conductors during installation. Ninthly, properly support the flexible conduit to prevent sagging and strain. Use conduit clamps or straps to secure the conduit to nearby structures. Tenthly, consult with a qualified electrician to ensure that the flexible conduit system meets all applicable electrical codes and safety standards. Always prioritize safety and compliance when working with electrical equipment.